Hi viewers, welcome to my channel Education Shop. In this video, solve example 3.8. It is taken from the heat and mass transfer by Cengel. This example 3.8 is relevant about heat loss through an insulated steam pipe. Steam at a temperature of 320 centigrade flows in a cast iron pipe and its thermal conductivity is 80 watt per meter Kelvin. This is the pipe. It is made up of cast iron. Inside this pipe, steam at a temperature of 320 centigrade is flowing in it. This pipe is made up of cast iron and its thermal conductivity is also given, that is 80 watt per meter Kelvin. Its inner and outer diameters are D1 at 5 cm and D2 5.5 cm. Inner diameters of the pipe is D1. Let's say the inner diameters of the pipe, that is D1, and this is outer diameter of the pipe, that is D2. D1 dimension is 5 cm and D2 dimension is 5.5 cm respectively. Pipe is covered with 3 cm thick glass wool insulation, and on this pipe the insulation provided. This is the insulation that is provided on this pipe, and the thickness of this insulation is 3 cm. It is also given in the statement, and the thermal conductivity of the insulation is 0.05 watt per meter Kelvin. Heat is lost to the surrounding at a temperature of 5 centigrade. The surrounding temperature is also given. It is T infinity 2, let's say, and its temperature is 5 centigrade. Natural convection and radiations with a combined heat transfer coefficient of H2. The outside environment convection heat transfer coefficient is H2 and its value is given 18 watt per meter square Kelvin. Taking the heat transfer coefficient inside the pipe to be 1, that is 60 watt per meter square Kelvin. Inside this pipe there is a steam. The steam also lost some heat loss to it. The type of heat loss within the steam is convection heat transfer. That's why the convection heat transfer coefficient inside the pipe is given, that is H1, and its value is 60 watt per meter square Kelvin. Need to calculate the rate of heat loss from the steam per unit length of the pipe. Also determine the temperature drop across the pipe shell and insulation. Let me write the data that is given in the statement. I hope you understand. Inside temperature of the steam that is flowing in the pipe, it is T infinity 1, let's say, and its temperature is 320 centigrade. Thermal conductivity of the material from which the pipe is made of, that is cast iron. Its thermal conductivity is, let's say, Kc, and that is 80 watt per meter Kelvin. Whose inner and outer dia of the pipe is also given. It is D1 and it is 5 centimeter. Convert into R1. R1 is the radius, inside radius of the pipe, that is equal to D1 divided by 2. We'll get a value that is 0.5 centimeter. Now again divide it 100, convert into meter. We will find the value of R1, that is 0.025 meter, and the outer diameters of the pipe is D2 and its value is 5.5 centimeter. Then the R2 value will be equal to D2 divided by 2, that is 5.5 divided by 2, and you will get its value, that is 2.75 centimeter. Divided by 100, convert into meter, that is 0.0275 meter. Next, the pipe is also covered with insulation. The thickness of the insulation is, let's say, X, and that is 3 centimeter. Convert also this into meter, that is 0.03 meter. Thermal conductivity of the insulation is, let's say, Kn, and it is 0.05 watt per meter Kelvin. And heat is lost to the surrounding at a temperature of 5 centigrade, that is, let's say, T infinity 2, and it is 5 centigrade. The outside heat transfer coefficient is H2, that is equal to 18 watt per meter square Kelvin, and the inside of the transfer coefficient is H1, that is 60 watt per meter square Kelvin. Things that is what we need to find, that is the heat loss per unit length of the steam pipe. Means to say the length of the pipe should be taken as 1 meter. Next, temperature drops across the pipe, temperature drops across the insulation. Let's come toward its solution. The inside surface area of the pipe is, let's say, 1, that is equal to 2 pi R1L. Put the values. 2 pi R1 value is 0.025, the value of L is 1 meter. You simply multiply and you will get the inside surface area of the pipe. This is the inside surface area of the pipe, and it is 0.157 meter square. Next, we need to find the R3 value. R3 is equal to R2 plus X. What is R2? This is the outer radius of the pipe, and we need to calculate this R3. If you look at here, it is the sum of R2 plus the thickness of this insulation, and that is given in the statement, and it is 3 centimeter. The value of R2 is also given. This is 0.0275 meter, and we can easily say that it is equal to 0.0275 plus thickness of the insulation, that is 3 centimeter, and it is 0.03 meter. Simply add it and you will find the R3 value. This is the R3, and that is 0.0575 meter. And that is, let's say, A3, and it is equal to pi R3 L. 2 pi multiply R3. R3 is 0.0575 multiply length, that is 1. Simply multiply and you will get its value of A3, that is 0.361 meter square. As we know that the heat is transferred from higher temperature to lower temperature. The higher temperature is inside the pipe, that is in the steam. The lower temperature is outside this insulation pipe, that is 5 centigrade. Thermal resistance network diagram is very important in order to find the heat transfer loss to such kind of questions. Let's consider this as a starting point from which heat losses occur. First, the heat is transferred from this steam toward its inside surface wall of the pipe, where the temperature is dropped to T1. The mode of heat transfer inside the steam is convection heat transfer, and the resistance that is offered to the heat transfer within the steam is Ri. So let's say starting point is infinity 1 and the temperature is 320 centigrade. Then resistance inside the steam is Ri. The temperature drop to T1 is the temperature drop at the inside surface wall of the pipe, and this is the pipe. It is made up of cast iron, offers some resistance to the heat transfer. Also, the temperature drop to T2 is the temperature that is at the outer side of the pipe. This is, let's say, R1, and the temperature drop to T2. Next, this is the insulation that is provided on the pipe, and its thickness is 3 centimeter. It offers some additional resistance to the heat transfer in order to keep this steam pipe hot, so that's minimum heat loss occur to it. That's why we provide the insulation and offer the resistance R2 to the heat transfer, that is R, and then the insulation resistance drop to T3. This is T3. Then again convection heat transfer is occur outside this insulation. The temperature is 5 centigrade. So this convection heat transfer coefficient. So the outside the pipe there, the convection heat transfer, that's why it's offer resistance R0, and the final temperature drops outside the insulated pipe is infinity 2, and it is 5 centigrade. So the temperatures, the heat transfer start from 320 centigrade and the temperature drops up to 5 centigrade. And in between we provide different resistance in order to minimize the heat loss. That's why we provide some insulation over the pipe also. To find the individual value of each resistance that is offered to the heat transfer, first is the Ri value, that is equal to 1 divided by H1 A1, the surface area of inside of the pipe, 1 divided by this H1 value. This is 60 watt per meter square Kelvin. Just write the value. The surface area inside of the pipe is 0.157. Simply multiply, you will get its value Ri 0.106 centigrade per watt. Next is to find the resistance R1 that is offered by this pipe that is made up of cast iron. R1 resistance offered by the pipe, and it is equal to, since this pipe is made up of cylindrical shape, so the resistance in cylindrical coordinates, you know, that is equal to ln. This is the natural law. R2 divided by R1, the outer radius of the pipe divided by inner radius of the pipe divided by 2 pi thermal conductivity of the material from which the pipe is made of, multiply length of the pipe. The outer radius is 2.75 centimeter and the inner radius is 2.5 centimeter. Thermal conductivity of the material from which pipe is made of is 80, and this one. Simply solve this on calculators and you will get the R1 value, that is 0.0002 centigrade per watt. Next is to find the resistance R2 that is offered by this insulation that is provided over this steam pipe or insulation. Similarly, this insulation is also in a cylindrical shape. That's why the resistance coordinate must be in the cylindrical, and that is equal to ln R3 divided by R2 divided by 2 pi thermal conductivity of the insulation by ln, that is 1 ln. What is R3? R3 is 0.0575 meter, or in other words, it is 5.75 centimeter. So we can say 5.75 divided by R2 value, that is 2.75. Thermal conductivity of the insulation, that is 0.05 watt per meter Kelvin. Solve this on calculator, you will get the resistance that is offered by the insulation that is provided over the pipe. Let me calculate this on calculator. This is the value, the resistance that is offered by the insulation, that is 2.35 almost. Let me write it on notebook, centigrade per watt. Next is to find the outer resistance or not, and it is equal to 1 divided by H2 A3. H2 is 18 and A3 is 0.361. When you solve this on calculators, you will get its value. R0 is equal to 0.154 centigrade per watt. Let me insert the value of resistance that we have calculated, the value of Ri, R1, R2, R0. If you look at here, the resistance Ri, R1, R2, R0 are in series. Simply add it and you'll get the final total resistance, thermal resistance network diagram. We can say that's RT is equal to Ri plus R1 plus R2 plus R0. What is Ri? It is 0.106 plus R1 0.0002 plus R2, that is 0.35, R0 0.154. Simply add, you will get the total resistance of this network, that is 2.4 centigrade per watt. Was our first requirement, is to find the heat loss through this pipe per unit length, that is equal to T infinity 1 minus T infinity 2 divided by the total resistance that is offered, that is 320 minus 5 divided by RT, that is 0.4. When you solve this on calculators, you will get value of heat loss through this pipe per unit length. It is almost 121 watt. As we know that the heat transfer rate through the pipe is equal to change in temperature divided by corresponding resistance. If you are interested to find the temperature drop across the pipe, you have to put the resistance of the corresponding one also, that is pipe, the corresponding resistance of the pipe, and it is R1. And we can say that temperature drop across the pipe is equal to close to the pipe multiplied by resistance, the heat transfer by the pipe, that is R1. Q.1 value is 121, multiply resistance R1 value is 0.000. Simply multiply and you will get the temperature drop across, that is 0.02 centigrade. Next is to find the temperature drop across the insulation, heat loss per unit, heat loss, total heat loss, temperature drop across insulation, and its corresponding resistance that is offered to the heat transfer, that is R2. Temperature drop across insulation is equal to total heat loss multiplied by resistance offered by the insulation to the heat transfer, 121 multiply R2, value is 2.35. Simply multiply and you will get the temperature drop across the insulations, and it is 184 centigrade almost. And this is our final requirement of this statement. I hope you understand. If still there is any confusion, you can ask in the comment section. Subscribe my channel if you haven't subscribed yet, and share with your friends and colleagues. Thank you so much.